Hello. In this video, let's discuss another form of threat against AI accuracy. While prompt injection and jailbreaking focus on the immediate conversation between a user and a machine, a third and perhaps more insidious threat has emerged in the form of Generative Engine Optimization, GEO, and AI data poisoning. If jailbreaking is a direct assault on the model's character, and injection is a trick played on its logic, then GEO is an attack on the model's very perception of reality. As AI systems increasingly replace traditional search engines, they partially rely on crawling the live web to summarize information and make recommendations. This is especially true for systems that use retrieval-augmented generation, RAG, or search integration. As a result, this has created a new frontier for manipulation where the goal is not to break the AI, but to surround it with a fabricated consensus. By flooding the digital ecosystem with high volumes of AI-generated articles, blog posts, and fake reviews, actors can essentially vote a falsehood into the AI's primary knowledge base, ensuring that the model presents biased or even non-existent products as objective truths. A striking example of this occurred during a major international consumer protection investigation known as the 315 Gala, which highlighted how specialized tools can be used to manufacture truth out of thin air. In one testing scenario, investigators used a generative optimization engine to create a fictional health device called the Apollo 9. By deploying dozens of soft articles and technical-sounding reviews across a network of seemingly independent sites, they created a digital footprint that made the product look like a market leader. Within a very short window, major AI models began recommending this entirely non-existent device to users, citing its unmatched battery life and quantum sensors as if they were established facts. This case illustrates the consensus trap. Because AI models rely on patterns across sources, a coordinated wave of fake data can trick the system into believing that a lie is a widely accepted fact simply because it appears in multiple independent sources. Beyond individual product scams, this category of vulnerability extends into broader commercial and artistic realms. In the world of digital media, creators have begun using tools like Nightshade to perform a form of defensive data poisoning. Unlike malicious attacks that aim to deceive users or manipulate markets, originally Nightshade is designed to protect intellectual property by making unauthorized web scraping and training on images unreliable. By subtly altering pixels in ways that are imperceptible to humans but disruptive to machine learning models, it introduces corrupted signals into datasets scraped without consent. However, if enough of these poisoned images are ingested, the model's understanding of concepts, like cat or car, begins to break down, causing it to generate warped or nonsensical outputs. On the commercial side, context injection via search results has become a growing risk. A travel company might flood travel forums with AI-generated comments claiming a competitor's hotel is closed for renovation. When a traveler asks their AI assistant to find me a room at the competitor's hotel, the AI reads the poisoned forum posts and provides the false update, successfully redirecting the customer to the attacker's business without the user ever realizing they were manipulated. This dynamic echoes the big lie principle described in Joseph Goebbels', though somewhat inaccurate, during the Nazi era, in which repeated and widely disseminated falsehoods can acquire the appearance of truth. In modern AI systems, however, this effect is not psychological but statistical. Repeated claims across sources can increase the likelihood that a model treats them as credible. The danger of GEO lies in its invisibility to the average user. While a jailbroken chatbot might sound erratic or a prompt-injected assistant might perform an odd action, a poisoned AI recommendation often sounds perfectly reasonable and helpful. It uses the model's inherent tone of authority to deliver misinformation that was planted days or weeks earlier on the open web. This creates a massive challenge for developers, as the attack surface is no longer just the text box where the user types, but the entire public internet. Protecting against this requires moving beyond simple keyword filters and toward complex provenance tracking, trying to determine not just what a piece of information says, but where it came from and whether it belongs to a cluster of suspiciously coordinated AI-generated content. Countermeasures against geo and data poisoning exist, but they require a multi-layered approach, because the attack targets the broader information environment rather than just the model itself. One of the most important defenses is strengthening source trust and provenance by prioritizing reputable publishers, applying domain credibility weighting, and adopting standards such as those promoted by the Coalition for Content Provenance and Authenticity, C2PA, to verify the origin and integrity of content. For AI systems that rely on retrieval, such as RAG, defenses include diversifying sources, detecting contradictions across documents, and identifying suspicious patterns such as sudden bursts of similar content, all of which help mitigate the consensus trap. At the model level, training techniques can encourage uncertainty awareness and resilience to noisy or adversarial data, though models remain limited in their ability to truly verify truth. Additional protections involve careful curation of training datasets, detection of coordinated content campaigns, and user-facing transparency features that expose sources and confidence levels. Ultimately, geo is particularly challenging because it expands the attack surface to the entire Internet, meaning that effective defense must combine technical safeguards with broader ecosystem efforts, such as content verification, platform governance, and digital provenance tracking. In conclusion, prompt injection, jailbreaking, and geo represent the three different ways an AI system can be compromised. Prompt injection is an attack on the input, where a user hides a malicious command inside data to hijack the model's immediate behavior. A useful analogy is the insertion of a forged memo into an otherwise legitimate stack of documents, subtly altering the outcome of a decision. In contrast, jailbreaking is an attack on the alignment and the safety guardrails, where a user employs psychological or rhetorical pressure to force the model to ignore its internal safety measures. This resembles a social engineering attempt, in which an intruder persuades a security guard to grant access against established rules. Generative engine optimization and data poisoning operate at a different level altogether, an attack on the environment. Here, the adversary corrupts the external information ecosystem on which the model depends. A fitting analogy is the systematic filling of a library with fabricated history books, such that anyone relying on its contents will unknowingly absorb falsehoods. While injection and jailbreaking turn the AI against its owner or itself, geo turns the AI's world against the user, making it a highly effective tool for fraud and unfair competition. As AI continues to evolve from a chatbot into a primary lens through which we view the world, the integrity of the data that feeds that lens becomes as critical as the security of the software itself. So, what's your take? Among prompt injection, jailbreaking, and geo, which poses the greatest risk? Ultimately, while artificial intelligence is a powerful tool, like any technology, it can be misused. For educators, this underscores the importance of encouraging students to verify AI-generated information and to engage with these tools responsibly and ethically. I'd be interested in your perspective. Feel free to share your thoughts in the comments. Thank you for watching. Goodbye.